Every year, approximately 2 billion low-tech pencils are sold in the United States, while a staggering 14 billion are sold worldwide. In the action-packed film franchise, John Wick, portrayed by Keanu Reeves, is infamous for his skillful and lethal combat techniques where he dispatches several adversaries using nothing but a pencil. The remarkable journey of a pencil starts with the careful procurement of essential raw materials. Pencils were originally made with a material called plumbago, which is a naturally occurring form of graphite. Nowadays, the primary components of a pencil include graphite, clay, and wood. Graphite, a naturally occurring form of carbon, is meticulously extracted from various locations across the globe. The highest quality graphite, known as vein graphite, is sourced from Sri Lanka and Madagascar. Simultaneously, the clay required for the pencil's core is diligently collected from deposits and quarries. This clay plays a critical role in determining the pencil's hardness and the darkness of its lead. In addition to graphite and clay, wood assumes a pivotal role in the construction of a pencil. The most commonly used wood is cedar, specifically California cedar. This choice of wood is not only abundant but possesses a pleasant odor and retains its shape without warping. Pencil manufacturers consistently prioritize sustainable forestry practices to ensure responsible sourcing of wood. Upon obtaining the necessary raw materials, the meticulous process of preparing the pencil cores commences. Firstly, the graphite and clay are ground into fine powders separately. The ratio of graphite to clay determines the hardness of the pencil lead, with higher graphite content resulting in softer leads and vice versa. Next, the powdered graphite and clay are carefully mixed with water to form a homogeneous paste. This paste undergoes a refining process to guarantee uniformity. Subsequently, the mixture is extruded through a specialized machine to shape it into long, thin rods. These rods are then cut to the desired length, corresponding to the final size of the pencil. The process of mixing graphite with clay traces its origins back to a chemist named Nicolas Jacques Conti. Interestingly, his discovery emerged during a graphite shortage in the late 18th century. Conti found that by mixing powdered graphite, clay, and water, molding the mixture, and subjecting it to baking, the resulting product wrote as smoothly as pure graphite. This groundbreaking invention continues to be employed in modern pencil production. The subsequent phase in pencil manufacturing is the encasing process, where the prepared graphite cores are encased in wooden slats, typically made from cedar wood. The cedar arrives at the factory already dried, stained, and waxed to prevent warping. The logs are then meticulously sawed into narrow strips, known as slats. These slats measure approximately 7.25 inches in length, 0.25 inches in thickness, and 2.75 inches in width. The slats are then fed into a conveyor system where they are individually dropped onto a moving belt at a consistent rate. As each slat progresses along the conveyor belt, a massive cutting wheel carves grooves into them, forming the channel that will hold the lead. Continuing along the conveyor belt, half of the slats are coated with a layer of glue, and the cut graphite is meticulously laid into the grooves of these slats. The remaining slats, without glue or graphite, are transported to a machine that flips them over so that the grooves face downward. The two conveyor belts ultimately converge, with each unglued slat precisely placed over a slat with glue and graphite, creating a sandwich-like structure. To ensure a firm bond, the sandwiches are then placed into metal clamps and subjected to hydraulic pressurization. They remain clamped together until the glue has fully dried. Once the pencils have been successfully bonded, they proceed to shaping machines. These machines expertly cut the pencil slats into their iconic hexagonal shape, which is widely favored for its ergonomic design and resistance to rolling off surfaces. The shaping process occurs in two steps. Firstly, the upper cutter of the machine forms 3 sides on the top, followed by the lower cutter shaping 3 sides on the bottom. As soon as the bottom sides are formed, the pencils separate, each boasting its distinctive hexagonal shape. Following shaping, the pencils undergo a meticulous sanding process to achieve smooth surfaces. This step helps eliminate any imperfections while providing a comfortable grip for users. Furthermore, a protective coating is applied to enhance the pencil's durability and appearance. This coating, often a lacquer or enamel, is meticulously applied, and the pencils are subsequently dried and polished, culminating in a flawlessly smooth finish. Occasionally, pencils may undergo supplementary treatments, such as heat treatment, to augment their strength and resistance against breakage. Many pencils are equipped with erasers at one end, rendering them versatile tools for writing and rectifying errors. These erasers are typically crafted from synthetic rubber or a combination of rubber and other materials. The notion of affixing an eraser to a pencil can be traced back to the innovative efforts of Hyman W. Lipman. an American inventor whose 1858 U.S. patent was subsequently acquired by Joseph Reckendorfer in 1872 for a reported sum of $100,000. The process of manufacturing an eraser commences by introducing a batch of rubber into a mill. This rubber undergoes repeated passage between large heated rollers wherein various additives, including pigments, fillers, and vulcanizing agents, are interjected. The mixture is meticulously blended to ensure the uniform dispersion of the ingredients. Subsequently, the vital process of vulcanization takes place, typically within specialized machines known as vulcanization presses or vulcanizers. These machines are designed to apply heat and pressure to the rubber compound, inducing cross-linking of polymer chains and transforming the raw rubber material into a more resilient and enduring form. Vulcanization not only enhances elasticity and resilience but also optimizes the eraser's efficacy in removing pencil marks. To produce the plugs that will be affixed to the pencils, an extrusion process is commonly employed. The soft solid mixture is forced through a die, shaping it into an elongated cylinder. As the cylinder emerges, it is repeatedly severed, resulting in the formation of plugs suitable for attachment to erasers. A ferrule, composed of metal or plastic, is inserted at the opposite end of the eraser, and the assembly is securely fixed onto the pencil. While certain automated steps may be involved in this process, certain pencil assemblies are still manually constructed. Initially, pencils are often packaged in bulk quantities for distribution to retailers, wholesalers, and stationery suppliers. This bulk packaging entails packing substantial quantities of pencils into robust cardboard boxes, specially designed to accommodate various pencil sizes. These boxes can house hundreds or even thousands of pencils. For pencils intended for direct sale to consumers, retail packaging is employed. This type of packaging typically includes individual pencil sets or packs wherein the pencils are meticulously arranged and secured within cardboard, plastic, or blister packs. This packaging may also incorporate branding, product information, and barcode labels, facilitating ease of scanning at the point of sale. Due to the conveyor belt system employed during the manufacturing process, pencils undergo thorough scrutiny before being distributed to the public. Proficient workers are trained to identify and discard any dysfunctional pencils, while a select number are sharpened and tested to ensure optimal functionality. Although a common issue arises when the adhesive of the sandwich components fails to adhere, this inconvenience is typically detected during the cutting process. Despite the proliferation of electronic alternatives, the pencil industry continues to exhibit steadfast growth. Presently, the global market size of the pencil industry stands at $15.95 billion, with experts predicting a projected growth rate of 7% by the year 2028.